This is Abby's favorite month.
Okay, so we're going to continue with this example. So we were talking about the height of this ladder from the ground was 12 at that instant where we were wanting it to be 12 feet above the ground. We know that the length of the ladder is 20. I can use Pythagorean theorem to solve for the missing x. So 20 squared minus 12 squared equals x squared. X squared equals, I believe it was 256. 20 squared minus 12 squared. So x squared is 256. Because we're talking about a length, x is greater than 0. So when I square root, I'm only taking the positive square root, which is 16. And then I get negative 16 times 4 over 12. And you can either work that answer out or just leave it like that. And in this case, we get negative 16 over 3. And then the units would be how fast is the top of the ladder moving down? Feet per second. Now let's look at part B. It says to consider the triangle formed by the side of the house and the ladder, and find the rate at which the area is changing. So we want to find dA dt when the top of the ladder is 12 again, so when y equals 12. So now instead of using Pythagorean theorem, I'm just using an area formula. The area of a triangle is 1/2. My base is x, my height is y. I take the derivative of that expression. dA dt is equal to 1/2 x. And I'm going to use product rule here. So I'm going to do the derivative of the 1/2 x first, which is 1/2 dx dt plus, or times the second, which is y, plus, I'm going to leave the 1/2 x the same. The derivative of y is dy dt. And then I just sub in the values I have. 1/2. My dx dt was negative 16 over, not negative 16 over 3. My dx dt was 4 feet per second, so 4. My y is 12 plus 1/2. My x is somewhere 16. My dy dt is what I just solved for, negative 16 over 3. And again, I'm fine if you just leave your answer like that and throw some units in. So my units of area are feet squared per second. Now, classic example 4 type problems are referring to area problems. So with area or with angle problems, we might be given an angle in the problem, and then you need to take that angle and somehow write an equation with it. And sometimes we're going to use our SOHCAHTOA to do that. So this is just information for you. We just have to also remember we're always measuring our theta in radians. So find the rate, so find a derivative at which the angle between the ladder and the wall. So find d theta dt when the top of the ladder is 12 feet above the ground, so when y is 12. So same diagram as we had before, it's referring to the same information. This is x, this is 20, and our theta is here. So I need an equation. I have information about d theta dt, I have information about y. So if I look at theta, this is my opposite, my adjacent, and my hypotenuse. So I can use either tan if I want to do more work, or I can use cosine. So cosine of my theta is adjacent, which is y, the information I'm given, over my hypotenuse, which is 20. I'm going to kind of rearrange this formula. 20 cos theta equals y, and now I'm ready to take a derivative. So the derivative of 20 cos theta is negative 20 sine theta times the derivative of theta, which is d theta dt, equals the derivative of y, which is dy dt. And I'm interested in solving for d theta dt, so I'm going to isolate for d theta dt. So I'll divide both sides by the negative 20 sine theta. So d theta dt is dy dt divided by negative 20 sine theta. And now it just requires me to sub everything in. So dy dt is what I just solved for in the question above. Negative 16 over 3. Divide by negative 20. And my sine of theta is, now when I have the value subbed in at that specific instant in time, this is 20, this is 12, and this is 16 we calculated. My sine of theta is opposite over hypotenuse, which is the 16 over 20. So when we work that out, we get 1/3 radians per second, which is the units of theta with respect to time. The next most popular type of example are these Pythagorean theorem 2, and they start to deal with rates of change in cars and distances away from certain points. So at a given moment, a car is 30 miles north, and at that same given moment, 40 miles east. So that information given is sort of like the information when I hit exactly Red Deer, that's the information I know. So I don't want to represent that information in my diagram. So I have an intersection here, and a car is going to be traveling towards this intersection. So I'm going to label this direction as X. And at the same time, another car is east and then traveling away from the intersection. So I'm going to label this side Y. And Z is going to be the distance between the cars. So at the moment, car X is traveling. It's traveling towards the intersection, so this distance is getting smaller. The rate of change of that distance is dx dt, which is negative 45 miles per hour. My dy dt is getting larger because this car is moving away from the intersection. So I use a positive 35 miles per hour. And at the instant that X is 30 miles north and Y is 40 miles east, I want to find the rate of change between the two cars. And I want to know if that rate of change is increasing or decreasing. So I'm just going to look at the answer and decide if it's positive or negative. I need a relationship between my variables. So this will be Pythagorean theorem, because a car traveling north and a car traveling east would be at 90 degrees from one another. So x squared plus y squared is z squared. I take the derivative, 2x dx dt plus 2y dy dt is equal to 2z dz dt. My 2's can cancel out, so I'm going to go ahead and cancel the 2's out. I sub in my values that I've given now. So I want to isolate for dz dt, which I'm going to do first. And I'm going to get dx dt plus y dy dt. And I'm going to divide both sides by z. So now I'm just going to sub my values in. X is 30. Dx dt is negative 45. Plus y is 40. Dy dt is 35. Divided by z, which I don't know at the moment, but I can find it. So if I draw my diagram out and I use my 30 and my 40, this is kind of like your 3, 4, 5 triangle. So if I were to do Pythagorean theorem, this z would be 50. So I'm going to just go ahead and sub in 50 in for my denominator. And when you actually work this out, it just works out to a 1. So because this answer is 1, the distance between the vehicles is increasing at a rate of 1 mile per hour.